We continue to discuss chapter 14. Section 5, we study the seasons, like spring, fall, and summertime. So now, first, the air temperature in atmosphere depends on number one, the first one, the latitude. Look this model. Okay, equator, that's 0 degree latitude, and the North Pole is the 90. Okay, so from the equator to Tropic of Cancer, so that's 23.5 degree, we call low latitude. We only discuss the northern hemisphere. Now from Tropic of Cancer to the Arctic Circle, that's Arctic Circle. So we call middle latitude, then high latitude. Okay, so now the insolations, that's incoming solar radiation, come to the Earth. See the same size of light beam at low latitude going to cover smaller area, bigger in middle latitude, and much bigger in the high latitude. So that means we have more solar energy per unit of area here, less and much less. Okay, so that's one reason for temperature difference. The second one is the altitude. We now start from the sea level. The air density decrease when the altitude increase, right? So mountain area, like a mountain top, is warmer at noon because the sunlight directly to that area. But it cools very fast at night because it's the altitude. So we have less greenhouse molecules which can regulate temperature. So it's very hot during day and cools at night. So third one is the cloud. Cloud reflect solar energy. Okay, so now the region, the part of world with more or less cloud make very different temperature. The last one is specific heat. Okay, so we studied in chapter 5. So the specific heat is the energy or the heat per kilogram change 1 degree. Okay, so now near the ocean, because the water has the ability absorb more energy. So the summertime is not very not too hot, and winter is not too cold because the water can regulate temperature. But the land and the desert can be very different. Okay, so that's another. So also the distance from the sun to the earth. We say the earth circles the sun, but distance not exactly constant. It's ellipses, right? So that's average distance, about 100 million miles. Okay, but this distance will change 1.6%. Not much. So from January to July, the distance between the sun and the earth change. But the real reason is the tilt. The season changes because the tilt. Okay, look at this diagram. So here's the earth, the sun, of course, it's much small, much further. Okay, now see here's is the angle. Instead of straight like this, the angle like that. So Earth rotate, same time circle the sun. Okay, so now because that angle, the June 21st, that's summer start. So you have more solar energy come to northern hemisphere. The sunlight goes straight to the tropical Cancer. Okay, so if you live over there, Hawaii is only a state in U.S. Around this circle. So you're going to see the sun straight overhead. Okay, so now in the this circle here, we call Arctic Circle, right? So you're going to have a 24-hour daytime. The sunlight always come to this area at that day. Then you're going to change. Okay, can you go this way? And here's September. Okay, so now the sunlight go straight to equator. So you're going to have half day, half night. Okay, so now another 3 months come here. That is the December 21st. That is the sunlight go straight to the southern hemisphere. So we call the Tropic of Capricorn. Okay, so now the southern hemisphere is the summertime, and us is the winter time. Okay, so the Arctic Circle here gonna have a 24-hour night, no daytime. Okay, so then another 3 months at springtime, March 21st, 22nd. Again, the sunlight goes straight to the equator. So the reason of the season change because the tilt, T-I-L-T, is about 23.5 degrees. Okay, so here's table. I'll give you a little more detail. If you have time, you can study. And then I borrow this figure from another textbook. Okay, look here. Here's the Earth surface, the orange color. So suppose you stand here, face to north. Okay, like the St. Louis, and back to south. Let's say Dallas. Then that is the east on your right and west on your left. Okay, so now the summer times, the sun going to go this way. Okay, that is June 21st. So you're going to see sunrise from here, and then all the time, the daytime, okay, it's about 15 hours in the United States. 15 long hour of daytime. Okay, then you have night times from here back to, with your dash line to there. That's about 9 hours. Okay, so that's the daytime in summer. Now spring or fall, you're gonna go say like start from here and back to there. It's about 12 hours. 12-hour daytime and 12-hour nighttime. Okay, so now the winter, December 21st, about Christmas time. So if you stand the same location, you can see sunrise from here, then and there. So the daytime is only about 9 hours. So long night and short daytime. Okay, so that help you understand. So then, of course, other time is somewhere between. So start summer, then the sun will go this way, go that way, Finally, the spring or fall will go right here, and middle, then shift to south. So now section 6, we discuss the wind. So what is wind? Wind is horizontal movement or horizontal motion of the air in atmosphere, driven by pressure difference in atmosphere. Because pressure difference, the air always blow from the high pressure to low pressure, right? Just like you pump air to basketball. Always go from the high pressure to low pressure. The horizontal motion we call wind. The vertical one we call convection. So warm air goes up because warm air going to expand. Density drop, goes up, cools down. Then cold air come back to Earth's surface. So warm air goes up, then cold air goes down. This kind of vertical motion we call convection. So now here's a very important concept we call Coriolis effect. So let's remember the name, Coriolis effect. What is that? The Coriolis effect is the change direction, change direction of the wind. Or we say deflection of wind due to the Earth's rotation, because rotation of the Earth. Okay, so now we still discuss in the northern hemisphere. So now let's see what happens. Because the Earth rotate, Earth rotate. Okay, rotate go that way. Suppose wind blow along this line here, blow this way. Okay, but at the same time, the Earth rotate. So then what happens? So wind going to be land to little right. I mean, you start from this direction, we call that go to the right. So for example, the wind suppose blow from say Chicago to Little Rock, but because of rotation, so end up to Oklahoma City. Okay, so always turn to the right. Okay, then you see from this way. So start point, turn to the right. Because rotation of the Earth. Because rotation of Earth. Okay, so that's very important. We call Coriolis effect. In northern hemisphere, the path of the wind always turn to the right. Always turn to the right. Okay, so now on the southern hemisphere, going to be go to the left. But we're going to concentrate to the northern hemisphere. Okay, so now let's see, and we're going to study convection and Coriolis effect together. So now suppose here you have low pressure. Okay, low pressure because the warm air goes up. So now warm air goes up, then the air going to blow in from surrounding area. So now blow in, turn to the right, blow in, turn to the right, and blow in, turn to the right. Okay, so this area of the air going to circulate, always go this way. Well, in the northern hemisphere, like all the tornadoes always rotate that way. So now, if you have a cold air drop down, so the pressure going to be high. See, the cold air goes down, then push the air out, push air, blow out, flow out. Flow out going to be turn to the right, turn to the right, turn to the right. And this we call Coriolis effect. Wind always turn to the right. Well, on the northern hemisphere. So please remember that. And this motion can be very big area. Look like this. Okay, so you have a big circulation. Big circulation. Okay, so can be like a few hundred miles or even bigger. Rotate. So now this from the top view. If it's landing somewhere, well, that's a tornado. Okay. So now the last thing we're going to discuss some general circulation of the atmosphere. The circulation of atmosphere. First of all, we assume there is no rotation of Earth. So we make a very simple model first. Okay, we're going to discuss without Earth's rotation. So what happened is the equator, the middle part, the low latitude, receive more energy from solar energy. So from here, the warm air goes up. Okay, then until reach the stratosphere, the second region. Okay, the mostly happen in the troposphere. Okay, the first region. So until about 10 mile high, 10 kilometer, about 7 mile high, then what happens? Cannot go any higher. So then going to separate some, let's say half go to the north, half go to the south. Again, we're going to concentrate to our half. So now, so going to from high sky going to go north and cools down, then cools down. Of course, all around the Earth. So from everywhere around the equator. So this side, same thing. Okay, so all the air travel to the North Pole, then cools down, and then sink to the Earth's surface, then push out, just like this, because the high pressure. Then from, okay, so that's the high sky. Okay, then near the ground, going to blow back to equator. So this kind of circle. This side is a symmetric circle. Then from the land, from Earth's surface, they're going to see wind blow back to equator again, and same thing from the South Pole. Then the same thing again. Of course, it's too simple because we assume Earth is not rotate. But now the second model still is very the simplified model. So we're going to discuss what happens if with the Coriolis effect. Okay, so Earth does rotate. Then what happens? Well, a little complicated. Let's see. Okay, so now again we start from equator. The warm air goes up below stratosphere, then separate to the north and the south. Okay, so now when travel to this way, not only to the north, also turn to the right, because Coriolis effect. So if you see this part here, so wind blow, start from equator goes up, then blow to the North Pole, but same time turn to the right, turn to the right, turn to right. Okay, so now think about turn to right this way, then around 30 degree, around 30 degree of latitude, the wind, the air cannot go north anymore, so just stay this area around 30 degree, then finally goes down, Okay, so then goes down, then on the surface of Earth going to separate. Some travel back to equator, to the south, some travel to the north. Okay, so now at the same time, the North Pole area, the cold air always goes down and push out, then travel to the south. Okay, at the same time, because Coriolis effect, the wind is going to travel to this way, then turn to the right. See, turn to the right, then turn to the right. Now around 60 degree, 60 degree. Okay, so now you have warm air from the south and cold air from the North Pole. So they're going to meet each other. And also this go South Pole wind turn to the west. This go to the east. So warm air and cold air push each other, twist each other in this area. So the weather conditions so complicated. So that's where we stay. This area like United States. So now, so warm air lighter because low density or goes up when they push each other. So goes up. Okay, then cools down. Then from the high sky separate again. Some back to the south, some back to the North Pole. Okay, so basically we have three circles. One start equator, come to 30 degree and back this way and that way. At the same time, turn to the right, turn to the right, turn to the right. Okay, then this turn to right, turn to right. Okay, so then around 60 degree, the warm air and the cold air from North Pole meet each other and push, twist. Then some air goes up, then separate again. Part go this way, part go back to North Pole. So that's one circle, two circle, and three circle. Looks a little complicated. By the way, I will not ask you those details. Okay, but we should know what is the Coriolis effect. Okay, and here's some detail. Near the equator, warm air rise and flow to the north and turn right. When it reaches about 30 degree latitude, it goes down back to the surface, Earth's surface. Okay, so now at the surface, some air flow goes back to south, back to the equator, and some go to the north. Both turn to the right due to Coriolis effect. Okay, now about 60 degree, we call subpolar low. And now the warm air and the cold air meet each other, twist each other. The lighter warm air rises up until under stratosphere, about 7 miles. Then some air flow back to equator, and some air flow back to North Pole. So that's basically what happens. Okay, so now we're going to discuss a real situation. Because many factors change the influence the weather and the airflow, the pressure change on the Earth's surface. So it's very complicated. Okay, so now see this white line, this circle, we call equal pressure line. Okay, so the weatherman need to make this. They know which location and which other location they have the same pressure. Why? Because wind always blow from high pressure to low pressure. For example, this circle here, every point is 1,000 millibar. And this circle here, this curve, that's another equal pressure line. And every point is 1,005 millibar. Okay, so next one here is 1,010. So then you know how the wind is going to blow. Okay, so now we have totally 10,000 weather stations, okay, around the world. So they share information, use computer, right? Okay, so data on air pressure, temperature, humidity, and cloud cover, rainfall, everything, the wind, every information collected every 3 hours, then shared by all over the world. And more, we have more additional information is provided by satellite. Then computer put all the information together. Then we can have the best information about the weather. Okay, so now our last thing we'll discuss how we can read a weather map. Okay, it's like this. Again, this curve here, so this time we use the blue color. We call equal pressure line. Like every point along this line, 1020 millibar, and this line, every point is 1015. So you know the pressure distribution. Okay, so now this dot here tell you if the solid means cloudy. And then see this white one, the empty circle here, means clear sky, clear. Then this direction, this goes that way, and this goes that way, this goes this way, go that way. So tell you the direction wind blow. Wind blow this way, then wind blow that way. Okay, so now see the small flag, let's call this has 2, this one only 1, and here's 3. Tell you the speed of the wind. Let's just say 30 miles per hour. The 2 means 20 miles per hour. This 1 flag means the 10 miles per hour. Okay, and also you see this kind of small triangle here means cold air, cold front. Cold front move this way. Some semicircle, the round one, semicircle. This one means warm front. Warm air will go this way and go that way. Okay, so now give you the weather condition. So some detail right here. So the pressure, we have an equal pressure line, and we have warm front, the semicircle, and the cold front, the triangles, cloudy day, and the clear sky give you this small circle. Okay, so and more. Well, that's all we're going to cover. So chapter 14, we only study the first 7 sections. Thank you.